Okay, this is chapter 472, chapter 72, exercise 72. And we have teams where the first one to win 4 is going to be the winner. So obviously they're not going to play more than 7 games because at that point someone has to have won 4 games. So this is similar to a World Series if you're familiar with baseball. And we want to see, we also know that the stronger team in any given game has a 0.6 probability of winning. So they're not exactly equally matched. And we want to know the probability that the stronger team will win in 4, 5, 6, or 7 games. So we have this set up. Let's just plug in 4 here to take a look at the lowest. So notice that the lowest number of games would be 4. That would be the better team winning all four games, the first 4. So we'd have 4 minus 1, 3 choose 3. In other words, just 1 here. This would all boil down to 1. Notice that this term would cancel out for I equals 4. And we just have 0.6 to the 4th, which makes sense because 0.6 that they win the first game, the second, the third, and then the 4th. It gets a little more difficult now when we have 5 games. So what that means is they're going to lose one of them, but not just any one. It's going to be one of the first 4. Because if the better team won the first 4 games and lost the 5th, it wouldn't make sense because you wouldn't ever get to that 5th game. So that 5th game, we know that the better team will win. So there's really only 4 possible places where that loss could occur. That's why when we sub in 5 here, we get 5 minus 1 to be 4. 4 choose 3. So we're choosing 3 out of the first 4 games for the better team to win. And then 0.6 to the 4th, because no matter what, we want to know for the better team winning the series, if they're going to win, they have to win 4 games, and each one has a 0.6 chance. So that's never going to change. And here now, we are going to have one of the losses if they're going to win in 5 games. So we have 5 minus 4, which is 1. So that 0.4 is the one that they lose. If we go all the way up to 7 then, 7 minus 1 is 6 choose 3 because, again, the better team has to win their final game or they wouldn't win the series. So that would leave the first 6 games that are played. Any 3 of them they need to win. And in this case, 7 minus 4, there's going to be 3 games that the other team wins. This is going to be worst case scenario for the better team, assuming that they still need to win. So anything between 4 and 7 will follow that. Okay, here we have just a couple of twists from number 72. First of all, they're evenly matched now, so there's not a stronger team with 0.6 chance of winning. They both have 0.5 chance of winning any given game. And we're also trying to find the expected number of games played. So now we're not even as concerned with who's winning. We just want to know, on average, how many games are going to be played. So if we look, n equals 4, this would be, again, the quickest way that it could be over, which is this 1/2 to the 4th power. So for example, if team A won all 4 games, it'd be 1/2 to the 4th power. But because we're not concerned with which team wins, that's why we multiply it by 2. So this, essentially you could take the 2 out first and you're calculating the chance that team A wins in 4 games, and then just double it because team A and team B are equally matched, so it should be twice the probability of team A winning. For n equals 5, again, that 2 there represents we're looking at it from either way. So if you want, think of it from the perspective of one team first of all. So let's say, let's ignore this 2 and say we want the probability team A wins in 5 games. Well, again, if team A is going to win, they need that last game. So there's really only those first 4 games that they are going to lose 1 or win 3, however you want to look at it. So that's 4 choose 1 or 4 choose 3. Here's the 1/2 that they lost. Here's the 4 games that they won. So the game they lost, the 4 games they won. And that would be the probability that team A would win in 5 games. But because they're equally matched, we just double that to get include the probability that team B could win, and that would round up to 1/4. And same thing for 6 and 7. And then expected value, again, remember we're taking all the possible values of our variable, in this case n, and multiplying each of those by their respective probability. So 4 times 1/8, 5 times 1/4, 6 times 5/16, 7 times 5/16. Add them all up, we get this. What does that number represent? The weighted mean, the average expected number of games that you're going to play in a series, if the two teams are equally matched, is almost 6 games. Now, of course, if one team is considerably better, that number would probably go down, as we saw in 72.